Hello, ladies, gentlemen, other. So we've got a cool little switch here. This is a great small cabinet switch, as you can see. We've got 8 2.5 gig 802.3 BT active/passive PoE ports on this thing. We've got two 10 gig ports on it, plus a console port, kind of handy. This little switch here will actually run on 36 to 75 volts, and it draws a maximum of 11 amps. So this is the Hyconext HC as in Charlie, 8M as in mother, T2XP-UP-DC. This is a great little switch. They run about, I believe they're around $500-ish US, and you can get them from the Hyconext website. I'm not sure what dealers carry them, but in the box we got all sorts of stuff. We got our power cables and ground cables. Yeah, there's the ground cable right there. We've got rack brackets, which is kind of handy. There, the rack, here's the rack ears right here, sorry. Come on, brain. So we've got our rack brackets, our ears. We've got our lugs, our little, for our racks, as you can see, it comes matched, so you don't have to go digging around in your tool bag for mounting screws. And of course, you've got the screws to mount these to the sides of this thing, so it can have its nice Dumbo ears and mount in the center of the rack. Yeah, it's a great little switch. This is perfect for small cabinets. So if you're running a WISP, or if you're doing security cameras or MDU, and you need something that'll do 2.5 gigs for like wave radios, as an example, wave required 2.5, the tachyons, IgniteNet, anything like that that you need BT, a lot of power output, and you need 2.5 gigs, that's what this switch is for. So this is perfect. You've got 8. In a lot of cases, people will run 4 sectors, but of course, once you start getting up to the wave stuff, it's actually better to run the 30-degree stuff. So what is it? You'd actually have 12 access points to get full 360-degree coverage. But as we all know, if you're in any kind of region that's not a mountain or, you know, a desert, you're not going to get that many radios there. So we've got 2 ports here. That can be used either for 10 gig backhaul, or we can connect them into a larger 10 gig switch. We can connect them to a router with 10 gig capability. So this thing's a pretty good little device. And I mean, like, for a small site, it's exactly what the doctor ordered. It's perfect. You've got more than enough 2.5 gig ports for backhauls and access points. And plus, you've got your 2 10 gig ports on here as trunk for your router. So let's get under the hood. All right, so what do we got here? So it looks like natively, this simply runs on 48 volts. It's just got 48 volts right here, this whole board, right? But this is a little buck boost board that will take anything from 36 to 75 volts and give you your 48 volts, specifically your 48 volts. Now, I wanted to take this apart and show you something that I really, really appreciate that these guys did. So I'm going to take off this awesome little protection board. So this is the, it's just loaded with TVS diodes and MOVs. I was actually quite impressed to see that. And these fans, by the way, are pretty sexy. I'll power it up in a second. So let's get this board out. Look at that. So these are all, sorry, not MOVs. These are all fuses. They're self-resetting thermal fuses, okay? And these are tons of MOVs. So the whole idea here is that this thing is grounded to the teeth. I mean, this has tons of surge protection built into it. I mean, even if you look at the board here, there's even more TVS diodes on the board. So, I mean, I think the reason why this thing is so overprotected on the inputs is because, as you can see, it's a minimalist switch design where it's basically just it has the sock right here. Everything happens here, which means that if, for whatever reason, a surge event gets through to this chip right here, pop, you're done. Because now you've got to find a replacement sock for it, okay? And then, of course, the BIOS is over here. So the whole point is that we're going to protect this by a protection board. This is a beautiful protection board. Now, this is where the magic happens for the 24-volt stuff. So this is a, let's see here. Oh, no, I'm wrong. Sorry, I was misleading you. I just read it. This is for the brains. This is a 12-volt output. So this is the 12-volt bus right here. So this will feed the functionality for the board, which is usually 3.35 volts and 12 volts, feeding most of this stuff in here. Of course, most of the voltage regulation is done through tiny voltage regulators on the board here, which feed the components that require 3.3 and 5 volts. Let's take a, ooh, looky here. It looks like there's a serial header right there. But of course, we've got a console port over there. This is a, what do we got here? Yeah, that's pretty sweet. So we've got a serial header right there. And I believe that the buck for 24 volts is going to happen in and over here because I'm seeing some VRs, some onboard VRs here. Let's see. Yeah, and then there's switches all through there. So, I mean, yeah. Okay, so it comes in here, 48 volts. This goes to 12 volts for the brains of the board. And then over here is where the 24 volt adaptation happens for this. So let me plug this back in now. I believe that it goes in this way. And I can line this up like this with the screws and the mother-daughter header. So now let's fire this thing up. I want you guys to specifically hear the fans on this thing. All right. Ah, the satisfying sound of a server starting up. Yeah, these fans blow. I mean, they blow hard. They are pretty awesome. They push a heck of a lot of air. Man, like, look at the design on those fans. Those don't look like the Deltas that I'm used to. They're really high efficiency fans. Like, they actually like flap my shirt like a flag in the wind when they blow on me. So, another thing which I wanted to note as well, just a minor touch, but I don't think anybody would really appreciate this except for me. The power leads here are all silicone. These are all silicone wires. They're not PVC. I like that. It's got that nice rubbery feel to them, which means that they'll handle high temperatures as well. So, yeah, I mean, like, these are pretty sweet. This is just a great switch. I mean, like, honestly, you know, we've all been struggling using Ubiquiti switches, trying to find a MikroTik switch that's small and suitable, like the NetPower 16. There's Netonics on the table there for small sites, which are a fairly robust switch as well. But, I mean, this one seems to, I feel like it's more finesse, this particular switch. It's a little bit more enterprise designed for carrier. So, I mean, like, it's a great little switch. Now, something which I neglected to do is look at the spec sheet on this. So I want to go back over here for a second. Let me pause for a second. Okay. There we go. Moving over to screen cap. Let's take a look at this. So here's the data sheet. And as you can see, they've got the prices right up here. Tax included, $520. That's not bad for the switch. That's actually quite reasonable for such an awesome switch. So now let's take a look down here. Now they've got a couple of models here which are covered. We're looking at the DC models, so just ignore the power specs on this for a moment because it's not what we're trying to focus on here. Let's see. There's your power surge protection. Rated power is 300 watts max on both. The only difference between these two is one's AC, one's DC, right? This is the AC column, and this is the DC over here. Okay. Now you can see there is one difference in the power surge capability of the DC versus the AC, but there we go. So 300 watts, PoE rating, 280 watts max, reserve 30 watt, typical 250. That's the most important thing right there I wanted to look at. Let's see here, 80 gigabits per second backplane, nice. Let's see here. Oh, it actually lists the pins for the serial interfacing. Nice. Let's see here. Moving down the list a little bit. I hope you guys can read that clearly enough. If not, you can just go to Hyconext website. Let's see. Yeah, I mean, there's everything right there. They've been very thorough with what they're actually showing in the spec sheet. I mean, I've seen some really useless spec sheets. In fact, Ubiquiti's bad for that. This has some great information on it. Yeah, and by the way, the fans are 4-pin fans. So they actually, they're PWM with TAC. So you can actually see what the rotational speed is. Like, these are great little devices. And of course, by the way, they support SNMP as well, which is awesome. Everything in your network should support SNMP. If a device or a software does not support SNMP, that's a dead giveaway that it's not carrier class. Okay, just remember that, okay? All right, so oh, choose AC or DC. Let's go DC here. Oh, sorry, the DC one's actually 580, not 520. The AC one's 520. There we go. I don't want to sound like a liar. Yeah, there we go. So these are great switches. Now let's move on to the software section of things and take a closer look at the software. All right, let's take a look at the software on this bad boy. So as you can see, it supports IPv4 and v6. Not that many of us use IPv6 yet. Shame on you for not... No, I'm just kidding. I mean, IPv6 is a little bit of a mind bender. So what we've got here is, if you look on the left, those are all submenus of system. If you click on advanced, it'll bring up the advanced submenus. If you bring up status, it'll bring up the status submenus. Tools will bring up the tools section. Oh, it's got a cable tester built in. That's kind of cool. That's actually very cool. I mean, yeah. All right, so let's go over to system for a minute and take a look at what we have here. We've got our system information. We've got our IP addresses. Or IP address, sorry, duh. Okay, so this is where you can actually set your IP address. Nice. User accounts. Nice, we can set up our user account here. System time. God, I don't have the hair for the 70s. I mean, this is just... We're in 2025 now. Everybody's in a depressive state with slicked back, greasy hair from not showering for days. SNTP. Let's see here. So that's... Yeah, that's cool. We can actually set this up, enable it. And usually when you're running switches on your network, you want to make sure that they're all synced to a central time server. I usually try to make the primary router on the network the time server. If you're running LTE, it's especially critical to make sure that your timing is appropriately synced across devices, including switches. Heck, if you're using any devices that are proper telecom-grade devices that have GPS sync, you must make sure that the time on all of your devices is synced properly. So SNTP is critical. Loop prevention. Yeah, that's a thing. See, look, you can read the stuff at the side here and it tells you what it does. It's basically just to prevent loops. Here's your spanning tree. Cool. It doesn't look like it supports MSTP, though that could be a submenu somewhere else on there. Most of you will not be using MSTP as we run routed networks. System reboot. I don't think I need to describe what that does. And our factory reset, great. So now let's go to the advanced menus. All right, we've got our port settings where you can actually label or describe your ports and set up your duplex on them. And oh, look at that beautiful 2500 megabit per second functionality. PoE settings. This is different. So this little 8-port switch is different from the 16 and 24-port Hyconext switches, whereas you can actually change the power setting on every single individual port. Okay? Whereas on the other one, it's in groupings of 4. So just keep that in mind. And of course, here's your wattage where you can set the maximum wattage, which will help determine if the device has gone belly up because, you know, lightning has struck it or a careless rigger has stepped on a cable and shorted it out. EEE stuff is right here. You know, I should really know what EEE is, but you know what? You can make fun of me for that. It's just I don't use it very often. Port rate limit. Let's see here. This is kind of handy. We've got port mirroring. This works well with WireGuard, so you can actually do like, Wireshark. Why did Wireshark have to create or name itself so close to WireGuard, or the other way around? WireGuard. Why is it called WireGuard when Wireshark exists? For people like me with broken skulls, I mean, it makes it difficult to actually nail that down, but I digress. You can use Wireshark to collect data from ports with port mirroring. That's the purpose of that, and almost every switch supports it, which is awesome. Link aggregation. Here we go. So this allows you to bond your interfaces. Well, this is a 10 gig / 2.5 gig switch, so I mean, realistically, for its purpose, intended purposes, you probably will not need bonding on it unless you're doing a high availability setting, which honestly, most of you guys won't. VLAN settings are hidden right in here. The VLAN's set up a little differently on here. Like if you want to set up a port, I'm on port 1 right now, so I'm not going to touch that. Let's choose port 8. Or even better, let's just do something like I would normally do. So this is a trunk port right here. So we're going to make it native to 1001, which is what I usually do for my management stuff. and then you can tag your other interfaces in on it. So your in-band VLAN right now, you would change this to 1001 as well if you make your trunk port 1001, but I'm not going to do that. So basically, here's what you do. To make this interface part of a VLAN, this is the native VLAN it's part of, and then you have to reflect that here in the untagged VLAN list. Now, it's not really a list because you can only untag a port in a single VLAN, and that's just how it works. You do not want to be untagged in multiple VLANs, because if you do, you're going to cross-contaminate your broadcast traffic, okay? And then here is the VLAN that we're bringing in. So let me just see if I can set up a different example here, because you can, yes, so it's comma separation. So I can go like this, like that. So those tags, let's try it. Yeah, there, oh, nope, it didn't take it. Let's see here. It might have to be in order. One second, let me just try this. There we go. That's a learning experience. So now I can do my 102 here, like so. And I can do my 103. And then say this port here, I can make it 4001. You guys who know me and my practices, or actually read best practices, would understand what I'm doing right now. So this is now these are two backhauls right here, and this is an access point. It's native to 4001, but 1001 being the management VLAN is tagged through. So you can see it's very, very simple to configure this. Very, very simple. It's nice. You hit apply and it just applies it. So there it is. There's your VLAN setup, as you can see. Really, really easy to use. Just remember that this counts in order up. So I'm going to change these back now, because honestly, when I'm done this video, I like these switches so much that this is going to go under my workbench, right where I'm sitting. And it's going to become my new lab bench. So I do like to thank Hyconext for sending me this awesome switch to do a video for them on. And I do apologize for the delay on the video, but I've switched to Linux from Windows now on my main computer, and it has been a little bit of a, there's been some quirks when it comes to recording. Other than that, I'm pretty happy with it. All right, so now we've reverted it. Q and Q. So this is for nested VLANs. And actually what's cool is we could actually set up Q and Q on individual ports, it looks like. I have not played with this, and this would be a lab all on its own. But with many switches, it's either Q and Q's on or it's not. Let's see, IGMP snooping. This is really handy stuff right in here. Higher level guys are going to know what this is all about, and they're going to be like, oh, wow, that's handy. But of course, again, it's a standard feature of any layer 2 managed switch. Okay, access control list. Here it is. Storm control. This is great stuff. This is all enterprise functionality. Here's your status, your PoE status on the interfaces. SFP status. This is great. There's a lot of handy information in here. And then your tools here. Okay, we've already been in there. So that's basically it. Help. I need a lot of that. I don't get any. So there we go. That's basically all there is to the software of it. So, so I wanted to add a little something. So this is kind of an insert clip. Now I mentioned SNMP because SNMP is actually very important for network monitoring. I mean, some companies use API instead of SNMP to monitor things. Honestly, SNMP is so ubiquitous that there's no point in getting rid of it. I mean, it is fully secure if you set it up properly. And we shouldn't be catering to the masses that don't secure their equipment appropriately. So I've gone through all the settings on this just to make sure that I'm not crazy. And I've not been able to find SNMP anywhere. Let's see here. I'm not finding SNMP. Now, adding SNMP is not a big deal. I mean, that's something which can be added through firmware update if Hyconext chooses to do so. But just to make sure that I wasn't just missing it and it's buried somewhere that I couldn't see it. Because, you know, I'm ADHD and my brain is definitely busted, so it's difficult to find things sometimes. Let's take a look at what a ZenMap scan brings up. So you can see the usual culprits. Port 6, I don't even know what port 6 is. FTP's open, Telnet is open. We've got port 80 and 443, 199, but I'm not seeing 161 and 162 in here for SNMP. There's also a whole bunch of these other neat ports open down here. Let's see. Well, filtered, not open, but look what the scan pulled up. This is kind of interesting. Hey, can you just let me... There we go. So if we look here, we got 445, which is Microsoft DS. We've got 888, Access Builder. We've got 995, POP3S. 1025, Filtered NFS or 2S. 1065, Syscom LAN. 1078, Avocant Proxy. Let's see here. 1199, DMIDI. 1947, Filtered Sentinel... What is that? Sentinel SRM. 1971, NetTop School. 2007, Deck Talk. 2875, DXM, DX Message Base 2. 3017, Event Listener. 3306, SQL. 5102, Admin G. 6669, IRC. Interesting. 8045, Unknown. 8080 is HTTP Proxy. 9290 is Unknown. 10778, Unknown. 19283 is Key Server. The rest are unknown. 26214, 28201, and 41511. So that's what ZenMap actually picked up. And I don't know if it did an OS fingerprint. Let me just see if it did. Not seeing an OS fingerprint. Either way, you know, I just want to try something here just for giggles. I want to see what's on 8080. Unable to connect. Whatever. So anyway, I just figured that I would throw that in there afterwards because I couldn't find SNMP, and I mean, like, everything I use uses SNMP. So not seeing SNMP in here was actually kind of strange, and I have seen it buried before. I mean, if I click on Help, helpful hints. Actually, the help column doesn't actually seem to do anything. Okay, I'm hoping that that's just a Firefox bug, but apparently help doesn't do anything. Okay, there we go. I hope you guys enjoyed the video, and thanks for watching. Don't forget to like and subscribe, and if you want to help feed me, because I live in Canada, and, well, actually, the entire world is suffering from mass runaway inflation. You can thank your governments for that. Yeah, join my Patreon. Help keep me alive. Anyway, thanks, guys. Catch you later.